All right, so we're in 3.4, and what we're going to be doing is multiplying polynomials and then raising binomials. So the word binomial, so poly means many, bi like bicycle. I don't know. I don't know. Binomials, many terms to a power. So think about like x plus 3 to the 4th. Okay, how is multiplying polynomials like multiplying integers? Because we just finished adding and subtracting, most of you would be like, oh my gosh, it's going to be the same, huh, Ms. Johnson? Yes. And how can I use strategies that I know for multiplying binomials to multiply polynomials of higher degree? And what are the most efficient and accurate strategies for multiplying polynomials? So all of you are going to have your favorite, right? Like my favorite, if I was taught the, some people call it the area model, the array method, or the box, that's my favorite way. And since I learned that, I was like, man, I teach every single, student that I can that, and they're like, oh, so much easier because it's organized. There's no way you can forget everything. Your alternative is FOIL, which was great, except for if it's not, if you have more than 2 terms. Okay. So multiplying polynomials can require a bit of skill in the algebra department, but because polynomials are structured like numbers, remember we say, if it works in number land, it works in polynomial land or algebra land. Multiplication works very similarly. When you learn to multiply numbers, you may have learned to use an area model to multiply 12 times 15, the area model that related to this procedure that looks like this. Now, for those of you who've never used the area model, just kind of like be like, where is the 12? Look for the 12 here, right? And you're like, oh, there it is. It's right there. Good. So it's 10 plus 2. So we're separating out the place values, 10 and 2. And then you're like, okay, but Ms. Johnson, why does it say 10 here? Hold on, just give it a second. And then, so the original problem is 12 times 15. Where do you see 15? And you're like, oh, there it is. So one of the things that you need to know is whenever mathematicians talk about multiplication, we are usually referencing area in some shape and form, okay? So because we're multiplying, then we're really looking for the area of this rectangle. The rectangle is 15 by 12. And so we break it up, right? So 10 times 10, oh, that's 100. 10 times 5 is 50. Now, if I collect all these, do you see how it's 50? And 10 times 2 is 20. If I collect all these, you see how it's 20. And then 2 times 5 is just 10. So if you look, you can find this 10, you can find this 50, you can find this 20, you can find this 100. If I add all the parts together, I get my answer, which is 180. Okay. Continuing. So you may have used the same idea with quadratic expressions. Area models help us think about multiplying, factoring, and completing the square to find equivalent expressions. So if you also use the box method last year or the year before, this is kind of what it looks like. I'll show you a simplified version or generic, they call it the generic version in a second. So your point is, where is x plus 5, Ms. Johnson? Oh, it's up there. Oh yeah, this is kind of like your 15. Yeah. And x plus 2, where is that x plus 2? Oh, it's right there. It's x plus 2. And then when I multiplied it out, right, I got x times x is x squared. 2 times x is 2x. 5 times 2 is 10. And 5 times x is 5x. Okay. Okay, some people like drawing the generic rectangle like this. I don't draw it like this. I only draw it like this. This is the only part I use. I do this. And I keep those other people on the outside because then it's just easier to draw. So some people draw it like this. This is called a generic rectangle. So I write x plus 5 on the outside, x plus 2 on the side. And you can flip-flop these. This is okay. And just check it out. X times x, still x squared. X times 5, oh, that's 5x. X times 2, that's 2x. 2 times 10, 2 times 5 is 10. Very good. Okay, so then we're just going to continue on. So now it's your turn. What's the property that all these models are based on? Just multiplication. Now that you've been reminded of the past, you are ready to use this strategy. Okay, so can you try this using a generic box? So I gave you a box over, I gave you space over here. Can you draw a box? Doesn't have to be neat. And then can you fill out the length and the width and then fill out the inside? We'll check back in a second to check your answers. Okay, so you were supposed to multiply x plus 3 times x plus 4. And then x plus 7 times x minus 2. I peeked at some of your work. And I was really impressed because some of you like have this down, even with the negatives. Ooh, not so scary, right? So yeah, x squared plus 7x plus 12, that's perfect. And x squared, ooh, watch your minuses. Whoever this is, watch your minuses. Let's see. Yeah, those minuses you need to watch out for sure. Yeah, there you go. So for those of you who aren't watching out your minuses, you'll have this right, but you won't add them together. So once you have them in there, then you just multiply them. So I'm going to walk through like step by step, just in case you were a little bit lost here. So the very first thing that I do is I draw my generic rectangle, and I just didn't draw it out here because then I have more space and I like writing big, right? Okay, so here's my generic rectangle. I'm going to take one of these and put them across the top. I'm going to take the other one and put it across the side. So x plus 3 and x plus 4. And then I'm just going to multiply to get the insides. So x times x, that's x squared. X times 3, that's 3x. X times 4, that's 4x. 4 times 3, that's 12. Most of you got this, so I'm just kind of going through this. This last little step is you just adding the like terms. And here, x squared is by himself. 3x plus 4x is 7x. And then I got 12. That's it, Miss Johnson? Yep, that's it. So this one's a little bit tricky because of this negative. Again, I'm going to tell you over and over again, Miss Johnson walks very carefully whenever she sees negatives, just because she makes mistakes with negatives, as you guys saw earlier, right? So I'm going to go again. So x plus 7 goes across the top. I do x minus 2 like this so that I know that it's a negative right here. I know that this guy's a negative. So give me a second, let it catch up to me. Right, I put the negative like that. So do this with me, right? X times x is x squared. X times 7, that's 7x. That's not a problem. Negative 2 times x, that's negative 2x. And negative 2 times 7, that's negative 14. So again, adding these all together, right? Adding these all together. Sorry, it's still going. Oh my goodness, come on. Why no? Let's go. Boom. Okay, there it goes. So when I add all of these together, right, I'm just adding like terms. So again, x squared is going to be by himself. So x squared, 7x minus 2x is plus 5x, and then negative 14. Okay, so if you don't have these two answers in your thing, make sure you do. Make sure you practice. This is like one of those things that looks intimidating. It looks complicated, but in reality, it's not that bad. Okay, it's not that bad. Okay. So now we're just going to continue. So maybe now you remember some of the different forms of quadratic expressions. Factored form. So this is called factored form right here. This is called factored form right here. The reason why it's called factored form is because they're factors. This times this times this. That's what factor means. Like breaking it into its pieces, into its multiplication pieces. And then standard form, this is standard form over here. So let me just highlight so you guys all remember. So factor form looks like this. And then standard form looks like this. So standard form is the way they'll usually give it to you. Okay, standard. So these forms exist for all polynomials, although as the powers get higher, the algebra may get trickier. In standard form, polynomials are written in terms are in order from highest power squared to the least power constant. Okay. And then the lower power terms, so that each term it is of a lesser power than the previous. So here's some examples. So here's an example of it written in order. Right. Rarely will you ever see me write something like this, -9 plus x squared. I don't like that. That makes me think of like how Yoda talks, right? Bathroom have to go I. Like everybody understands what you're saying, Miss Johnson or Yoda, right? But it's not clear. So here's some cubic examples. Here's a quartic to the 4th power. So hopefully you also remember that you need to be sure that each term in the first factor is multiplied by each term in the second factor, and the like terms are combined to get the standard form. What did they just say? They just said that the first term is multiplied by everybody in the second factor. See, it's like some crazy distribution, right? You get to go with you and you to produce this. Now it's your turn. You have to shake hands with you and you. So there's this famous math problem, and it's called shaking hands. But I think about this, like everybody has to shake everybody else's hand from another family. So I think about this as a family, this is a family, and then you're shaking hands with everybody from the other family. So like my husband would shake everybody's hand from the other family, and then it's my turn. I would shake hands with everybody from the other family, right? And in me shaking the wife's hand, she's also shaking my hand. So it's not like I have to go back and do it. So that's what that first sentence says. And then it says you can use area models, boxes, mnemonics such as FOIL to help you organize, or you can check every time to be sure that you have all combinations. Everybody from one family went with everybody from another, right? It can get more challenging with higher powered polynomials, but the principle is exactly the same. And it's all based on the distributive property. Yes, guys, I took you back to 4th grade. That's when you learned that. So that's when you first learned it. So the next couple parts goes like this. So here's Tia's favorite way. She likes the box method. Okay. She likes the box method. Okay, so then it says, try checking your answer by graphing the original. I showed you how to do this. You're going to graph your answer in standard form. You're going to graph your answer in factored form. And you're going to see if they overlay, just like one of your classmates said. Then we have Tahani's favorite. And Tahani's favorite is like, it's like distributive property. So x goes with x squared, x goes with 4x, x goes with -2. -3's turn. -3 goes with x squared, -3 goes with 4x, and -3 goes with -2. So really, this is just a different organization of the same thing. Here, we organized it in like almost like a table format. Mrs. Johnson's favorite, right? She loves tables. And then here, Tahani is just like ignoring the -3 and then distributing. And then ignoring the x and then distributing, right? So then you have a choice, like which way ended up being your favorite. Great, use that way. Okay. Now, when we get to problems that look like C, how would you multiply this? Now, if this doesn't make sense, take yourself back to Numberland. Someone give me a number. Good. Someone said 4. Oops, still in highlighting. Someone said 6. Someone else give me one more number, 2. Perfect. Okay. If I told you guys, hey, can you multiply 4 times 6 times 2? How do you multiply 4 times 6 times 2? What would you do? How do you multiply 4 times 6 times 2? What would you do? Here, I'll give you a clue. What would you do first? Yeah, I just picked 2 of them to multiply. So if you like multiplying 4 times 2 first, do that. Okay. So the point is you can't multiply more than 2 things at a time. Like, you know how if I gave you like 10 numbers to add, you can line them all up here and add them. Well, in terms of multiplication, you only can multiply 2 things at a time. So if you wanted to do 4 times 2, then do that. So then you'd go x plus 3, x plus 2 times x plus 3. And then you take that result and multiply that by x minus 2. right? Same thing goes here. I'd multiply 4 times 2, whatever that is. So that's 8. And then I take 8 and I multiply that by 6. And that's my answer. Okay. This is where I'm going to pause. I'm going to have you guys check your, we'll check our answers next time. But this next part here really is the same. No, it does not. You can multiply whichever ones you want to do first, because multiplication is what we call commutative. When we come back, we will do this together, but I just need you to remember what squared means. What does squared mean? Very good. It means to multiply it by itself. So this would actually mean x plus 1 times x plus 1, right? So this is not like so crazy. And this one, x plus 1 cubed, would be x plus 1 times x plus 1 times x plus 1. Very good. Okay, so when we come back, we'll talk about this and moving on. But I really, really want you guys to practice these ones on your own. Okay, this is, again, this is like one of those things where you know how, like, it makes sense, but you actually have to practice it in order to, you know, really understand it. Got it? Okay.